Okay, kiddos, we are looking at Unit 8, Lesson 2. And this is the other way that we're going to be solving for a side using Pythagorean theorem. Okay, so what we're going to do is, what if we're given the hypotenuse? You've been doing work already, and you know that your legs are here on each side of the right angle. You know that this is A and this is B, or vice versa. And you know that across from the right angle is C, and it's the longest side, and it's also the hypotenuse. I know it's a weird name, but you'll get so used to it and it'll become really normal. But hypotenuse is the name of that. And that is a really long name for a side length, isn't it? Okay, so if we are actually given the hypotenuse, let's just say our hypotenuse is 13 and our B side is 5, what is this side length? Well, all you're doing, this is where your kind of algebra solving for x comes in. We've done this Unit 2, we've done it many times this year, and it is where you are isolating a variable, or you are getting your a squared by itself. So we know we have a squared, but we don't know what it is. And that's kind of what we're solving for. Now, we know that our b squared, our b is 5. So we're going to square that, and we know that our c is 13. So you just put it where it goes. Kind of like with surface area or volume. If it gives you the volume, you're solving for radius, well, you know you just move everything away from what you're looking for. So that's what we're doing here. So we've got a squared plus 5 squared, which is 25, equals 13 squared, which is 169. Can you look at this equation and say, I can solve for a? Your job is to get a by itself. So in order to have a by itself, you have to move over anything else that's on the a side, right? So we want to get rid of that 25. We want to move it over. So we don't want it to be positive. We want to do the opposite to move it. So positive 25 and negative 25 is nothing. It cancels itself out. And if I do it to one side, I do it to the other side. So I'm left with a squared over here. Well, we've got to subtract this. Use your calculator or do it by hand. And we get 144. So what do I do now, guys? We've done this for the whole first assignment. How do I get a by itself? Right now it's a squared. We take the square root. Boom. That pulls out, that separates my a's from each other and just gives me 1a. And what times what that's the same to make 144, square root of that is 12. Boom. 5, and instead of an x, I've got 12. That is what you do if you're given the hypotenuse. That's how you solve it. You just go backwards. So let's do another one. We'll say here's our triangle, and I'll do a weird one like this so that everybody's not always seeing the same exact way. We'll say we know that this is A, and we know that this is B, and we know that this is C because it's across from the right angle and it's the longest. Okay, so if I have 25 here and I have 24 here, what is this one? Well, I know this must be A and B, and this one is C. So I'm just going to fill it into my formula. A squared plus B squared equals C squared. I know that this is 25 squared, and I know that my A is 24 squared, and I'm looking for my B squared. So I'm just going to make sure that I keep my B squared right here. So I need to move this over to this side. So let's take it away from this side. If we do it to one side, we do it to the other. And now we're left with our B squared. Well, let's see what that is. Put it in your calculator. What is 25 squared, guys? 625. What is 24 squared? Put it in your calculator, y'all. 576. Now I'm just going to say 625 minus 576, and I get 49. So now I want to get B alone. So anybody who puts 49 here, no banana. It's not correct because that's for B squared. That's for two of them. So that's for 49 times 4. I mean, that's for, yeah, 49 times something is 49. So we need to figure out what two things that are the same make up 49 because we know that B times B is B squared. Square root, square root. What is the square root of 49, kids? Put that in your calculator. Boom. 7. And isn't that an unlikely number to go with 24 and 25? But if you actually write it out and say 7 squared plus 24 squared, that actually does equal 25 squared. It is a Pythagorean triple. So I'm going to talk to you about the triples real quick. And I want to tell you the reason that I know how to, whoops, let me get my pen again. The reason that I knew how to label all these triangles I've been giving you examples with is because I know my triples. So the triples are actually sets of 3, like 3, 4, 5. That's a triple. And I know this is my C because it's the biggest. So this has to be A and B, and it doesn't matter which order. So even if I doubled this and said 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10, that is still a triple because proportionately 3, this is what it means right here. Look at this picture. It means that 3 units, this, and this, are equal to, or plus 4 units on this side equal 5 units on this side. So let's just say I had 5 on each thing. So it'd be 5, 5, 5, 5, 5, 5, 5, and then 5, 5, 5, 5, 5. I'm not going to have any number that I'm using all the way around it. But this is 1, 2, 5, 10, 15, 20, 25. So this side would be 25, 5, 10, 15. This is 15. And this would be 5, 10, 15, 20. That is a Pythagorean triple. 15, 20, 25. Because it's basically times 5 for each one of these numbers. Instead of 5s, I could have put on each side, oops, I could have put 4. 4, 4, 4. 4, 4, 4, 4, 4, 4, 4, 4, 4, 4, 4. Okay, so here's all my 4s. This would have been 12. 4 times 4 is 16, and 5 4s is 20, correct? So 12, 16, and 20 is also a Pythagorean triple because it has the ratio of 3 to 4 to 5. So these are the 3 that I ask kids to put to memory. 3, 4, 5, 5, 12, 13, and 7, 24, 25. So these are the main Pythagorean triples that you work with a lot and that test makers use when they're giving you triangles. Just don't forget that they could double any of them. So this could be 10, 24, 26. They could double these and say 14, 48, and 50. You know, any variation of these is still a triple because it's the ratio of 3 to 4 to 5. So if I lost you there, that's okay. You can just keep checking your formula and using it to see if it is a Pythagorean triple. We'll talk a little bit more about that in class tomorrow.